3.26. Two stones are thrown up simultaneously from the edge of a cliff 200 meter high with initial speeds of 15 meter per second and 30 meter per second. Verify that the graph shown in the figure correctly represent the time variation of the relative position of the second stone with respect to the first one. Neglect air resistance and assume that the stones do not rebound after hitting the ground. Take G equal to 10 meter per second square. Give the equations for the linear and curved part of the plot. Means see here the plot, that is x2 minus x1. So x2 minus x1 represents position of stone 2 with respect to position of stone 1. So x2 minus x1 versus time t, the graph is plotted. And here the graph is a straight line up to 8 seconds. And after that it is curved one. And at 10 seconds, here the position x2 minus x1, that comes to 0. So we have to justify this particular graph and we have to give the equations for this linear and curved part of the graph. Clear the question? Now solution. See, we have the equation for the position of the object x, that is x0 plus v0 t plus half at square. So for first stone we can write position x1, that is equal to initial position 200 plus it is thrown with initial velocity v0, that is 15. So 15t plus half a, that is minus 10 into t square. So position of the first stone at any time t, that can be given by equation x1 equal to 200 plus 15t minus 5t square. Clear up to this one? Now for second stone, the position at any time t x2, that is initial position 200, it is thrown with initial velocity 30, so plus 30t plus half minus 10 into t square. So x2, that is 200 plus 30t minus 5t square. So this equation, first one give you the position of stone 1 at any time t. This second equation gives you the position of the second stone at any instant t. Clear? Now we want position of 2 with respect to 1. So position of 2 with respect to 1, that is x2 minus x1, that is equal to 200 plus 30t minus 5t square minus 200 plus 15t minus 5t square. So this 200 minus 200 cancelled. 30t minus 15t, so that is 15t, minus 5t square, and this minus plus 5t square again cancelled. So you will get x2 minus x1, position of stone 2 with respect to position of stone 1, that is 15t. So see, 15 is constant one, means x2 minus x1 proportional to t. So this is the linear relationship, linear proportionality is there. So the graph of x2 minus x1 versus t, that will be a straight line. Clear to all of you? Now see, when stone number 1 hit the ground, it will hit the ground first because initial velocity of stone number 1, that is less than the stone number 2. So when it hit the ground, its final position, that is 0. So In the equation x1 equal to 200 plus 15t1 minus 5t1 square, substitute x1 equal to 0. Then we will get 5t1 square minus 15t1 minus 200 equal to 0. Take 5 common from this one. You will get t1 square minus 3t1 minus 40. Then if you solve this quadratic equation, then you will get the time, that is 8 seconds, because negative time is not permissible. Means we can say here after 8 seconds first stone will hit the ground. So after that, whatever is the position of second one, that is the independent position. Therefore, your graph is a straight line only up to 8 seconds. Clear to all of you, beta? Now, after 8 seconds, only the second stone is in the air. So, its position, that is independent one, or we can say that is with respect to ground. And for that, we have the equation x2 equal to 200 plus 30t2 minus 5t square. And here in this equation, we can observe this thing, the position of the second stone, that depends on t square resultantly. So for this quadratic equation, if you draw the graph of position versus time, then that will be parabolic one. Therefore, it is curved one. Now, at what time second stone will hit the ground? So when second stone hit the ground, its a position, that is again we can take 0. So take x2, that is also equal to 0. Then you will get 5t2 square minus 30t2 minus 200 equal to 0. Again take 5 common. So t2 square minus 62 minus 40 equal to 0. Solve this one. You will get the time t2, that is 10 seconds. So in graph, we can observe at 10 seconds, the position, that is 0. Clear to all of you? As there is a linear relationship between x2 minus x1 and t, so the graph is a straight line OA up to t equal to 8 seconds. After t equal to 8 seconds, only the second stone is in motion. So the graph is parabolic in accordance with quadratic equation. And the second stone will hit the ground at 10 seconds. So after t equal to 10 seconds, the separation between the balls, that is 0. Clear? So in this way, the graph is justified, as well as the equations are also prepared for it. Clear?